Welcome to the Wisdomine Knowledge Series for CAT aspirants. In this module, we shall cover the topic permutations and combinations. In this session, we shall study some fundamental principles that are essential to solve any problem in the area of permutations and combinations. Contrary to popular belief, permutations and combinations is one of the easiest topics in mathematics to copy. Why do we say so? For starters, all questions in this area have the same format, which is as follows. The number of ways in which this task may be accomplished is. Every question has a task to be accomplished. There are conditions that need to be followed, and our task as a problem solver is to identify the number of ways in which the task may be accomplished subject to the conditions given. This means that permutations and combinations is essentially a counting exercise, which is why we said that it is one of the easiest topics in mathematics to copy. Let us look at a simple example of what we said. There are two roads from Mumbai to Pune and three from Pune to Bangalore. In how many ways can a person drive from Mumbai to Bangalore via Pune? The first thing that strikes us is the phrase "in how many ways." This tells us that the problem is essentially a counting exercise. The second thing that strikes us is that the broader task traveling from Mumbai to Bangalore consists of two sub-tasks to be done successively. These are traveling from Mumbai to Pune and traveling from Pune to Bangalore. We also note that there is a specified number of ways in which each of the two sub-tasks can be done. In this case, task 1 may be accomplished in 2 ways because there are 2 roads, and task 2 may be accomplished in 3 ways because there are 3 roads. This brings us to the first counting principle, one of the most important concepts to learn in the area of permutations and combinations. This principle reads as follows. If one task can be done in m ways and another in n ways, the two tasks can together be done in m into n ways. This principle may be applied when the following condition is satisfied. The tasks that need to be accomplished jointly should be independent of each other. This in turn means that the number of ways of doing the second task is not influenced by the particular way in which the first task is done. Let us illustrate this principle in the same example that we identified a short while ago. As specified in that problem, let us mark the 2 routes that are available to travel from Mumbai to Pune as A and B, and the 3 routes available to travel from Pune to Bangalore as 1, 2, and 3. One way to answer the question is to enumerate all possible combinations of routes that the person may use to travel from Mumbai to Bangalore via Pune, and that is what we shall first do. The enumeration will look as follows. The routes are A1, A2, A3, B1, B2 and B3. Here A1 stands for the route that consists of route A to travel from Mumbai to Pune, followed by route 1 to travel from Pune to Bangalore. While such enumeration is feasible and possible in such cases where the number of ways in which each task can be accomplished is small and the number of tasks to be accomplished simultaneously is small, in other cases it becomes fairly cumbersome and we are in need of a far more elegant way to accomplish our counting exercise, and that elegant way is provided by the first counting principle. We may note that the 2 tasks traveling from Mumbai to Pune and traveling from Pune to Bangalore are independent of each other, because whether he chooses A or B to travel from Mumbai to Pune, all the 3 routes 1, 2 and 3 are available to travel from Pune to Bangalore. This means that this is the perfect case for application of the first counting principle, where small m is equal to 2 and small n equal to 3, and the number of ways in which he may travel from Mumbai to Bangalore via Pune is m into n, or 2 into 3, that is 6. We now come to the second counting principle, the other important concept to be learned in the area of permutations and combinations. This principle reads as follows. If a task consists of two possible mutually exclusive courses of action capital M and capital N, given that capital M can be done in small m ways and capital N in small n ways, the task can be done in small m plus small n ways. The key word or phrase is mutually exclusive. What this means is that while we have two courses of action capital M and capital N, adopting course of action capital N means that course of action capital N may not be followed, and vice versa. Which means that if we choose to do the task in any one of the small n ways allowed under course of action capital M, none of the small n ways allowed under course of action capital N may be followed. Let us use a simple example to illustrate the second counting principle. Consider a person who has 4 shirts and 3 t-shirts and needs to dress his upper body in one garment. Clearly, because he can wear only one garment on his upper body, the two courses of action, wearing a shirt and wearing a t-shirt, are mutually exclusive. On top of this, we note that there are 4 ways to follow the first course of action and 3 ways to follow the second course of action. Therefore, by the second counting principle, we may say that the total number of ways of dressing the upper body is nothing but m plus n, or 4 plus 3, that is 7. This brings us to the end of this session. In the next session, we shall see how to apply these principles to solve a type of problems called arrangements. Until then, goodbye and good luck.